Hi everybody and welcome to week 3 at Rasmussen College. This is Chemistry 1100c and here's our presentation for this week. We are now into our third week and what we'll do is I will go over what we'll be covering. We'll immediately go into the passphrase so you have that. We'll go over the plan for the week and how to get through everything on schedule. Talk about the topics that you need to understand, show the videos that are available for each of those. Not play the videos, but just review them. And then we'll go over the 2 labs that I think are pretty straightforward this week. And then the assignment itself. Don't forget that for all of these, I do have what we call templates that you can make a copy of, and it should make the submission process easier. I'd say a little less than half of you are using them. It's your option. I'll accept whatever form for the assignment you give me. I think these are particularly useful. And then we'll go over the review and we'll wrap it up. So let's go ahead and begin. This week's passphrase will be Happy Thanksgiving. No surprise. For many of you, the the holiday may be just beginning. Okay, so the things we're going to be learning this week are a lot of things about bonding and gravimetric analysis and a little bit about acids and bases, and we'll have a short video you can watch for each of them. So once everything's all set, you'll know how to differentiate and utilize ions. So you'll know the difference between an atom, which is uncharged, and an ion, which may be charged. It might be an anion, meaning negatively charged, or a cation, meaning positively charged. The key thing to look for there is that when the number of electrons equals the number of protons, you have an atom rather than an ion. If it has an extra electron, electrons being negatively charged, you have an anion, a negative ion, anion. And if you're short an electron, well then you'd have more protons, which are positively charged, therefore you'd have a cation. And the behavior is predictable either by just looking at a periodic table and looking for the charges at the top, or by realizing that all of the columns will modify their number of electrons so that they have a full outer shell. For example, if you had 7 valence electrons, you'd gain 1 to have 8. If you had 1 valence electron, you'd lose 1 to reveal that full outer shell underneath. And the outer shell is known as the valence electrons. Here's some of the reading and activities that are recommended in Blackboard. You can use these. You can watch some of these. You can watch none of these. You could watch all of these. I do recommend you have a look at the slides that I'll be showing in just a minute that have brief videos associated with them. We do have 2 labs, and then we have our assignment and our quiz, and you're looking at right now the live classroom. The whole thing will total up to be worth 150 points, and here's how it breaks down. Okay, here's the videos that we have available. Here's some stoichiometry videos, so introducing you to the mole and how to do conversions, gram to mole, things like that. A couple of these topics right here aren't strictly required if you look at what will be covered, but they fit in so well I thought I'd throw them in anyhow. And then a little bit about bonding and electron dot structures is right here. And then you're also supposed to know a little bit about acids and bases, so I listed the 6 strong acids here and some of the weak ones there. By a strong acid, people mean that H plus that all acids contain here will dissociate completely, just like a salt, just like a sodium chloride would dissolve fully when you throw it in water. Here, these will fully turn into H plus and HSO4 minus, H plus and Cl minus, etc. They ionize. The solution becomes conductive. These ones over here, though, and you've probably heard of some of these, acetic acid, for example, sure, they're acids, but they don't give up their H plus very readily. To a certain extent, they just really, mostly, they just dissolve. They will ionize a little bit. You'll see a change in the pH. It'll go down a little bit, but nowhere near as much as these ones. Now, to say that they're weak or strong is not to say that they're concentrated or dilute. That's a different thing. That simply would be how many molecules of these acids are present in the solution, regardless of whether they ionize or not. Now, the first lab is a mineral composition lab. All you need to do, and I think you'll find this is pretty straightforward, is understand what an empirical formula is and watch this example where we calculate one from a percent composition. And then you use that knowledge to go ahead and click on this link here where you're given a similar problem, figure out an empirical formula, get that correct screenshot, and you are good to go. Just to say a few words about it, an empirical formula is the simplest ratio of atoms in a substance. For example, you may have a substance which has a 1 to 2 to 1 ratio of carbon to hydrogen to oxygen. Its empirical formula would be CH2O. However, each molecule might be some multiple of that. For example, C2H4O2 would belong to that empirical formula, but you have to scale it up to get the molecular formula, and that will be coming up. So that's the first lab. The second lab is one of those, watch a little video from starting here, so you would click here, and then take a whole bunch of screenshots where each one has just a little puzzle they ask you, you solve it, you get the correct screenshot, and these are literally the slide numbers so you can be sure you know what you're taking pictures of. So it's 81, 82, 83, right through 85, and then 87 through 93, and then 96 through 105, and yes, and that would be get you through the second lab. After that, all you need to do is the assignment, and here's the assignment questions. I think I'll take a quick peek at some of these for you here and give you some hints to get you started. This one's solved for you. You have 3 moles of oxygen. Well, don't forget the mole is just a number, 6 times 10 to the 23rd. And so anytime you have 3 of those, it would be 18 times 10 to the 23rd, right? That would be 3 moles. We modify it slightly, so we start with a number between 1 and 10, so 1.8 times 10 to the 24th would be 3 moles worth of oxygen. Now, if you had 5.87 times 10 to the 21st molecules of sulfur, you'd be about at 1/100th of a mole, because you need 10 to the 23rd to have a full mole. So I bet this would come in at a little bit less than 0.01 moles. And now once you have your moles, you can now convert to grams, because for sulfur, 32 grams is a mole. Similarly, if you had 4.2 grams of magnesium, recognizing from the periodic table that about 24.3 grams is a mole, it sounds like that would be 1/6 of a mole. So rather than being 6 times 10 to the 23rd atoms, you have about 1/6 of that, or 1 times 10 to the 23rd. And if you watch the videos, it gives you a nice predictable way to do these conversions mathematically. So that's a little introduction to some of the assignments you have. We'll also name some acids. That shouldn't be too bad. And we'll cover topics such as polar, nonpolar, covalent, and ionic. That's bonding. So when you watch the bonding videos, you can learn a little bit about that. Let me go back to just take a peek at the videos so you can see the ones that will cover all that stuff. All of the core learning can be covered by watching these videos. And I'm going to click here to show you the playlist. And there it is. So it starts with an introduction to the mole. You work right down through this. If you start by just clicking here, it'll play every one of them in order without stopping. They're not too long, right? 4 minutes, 4 minutes, 5 minutes, 3 minutes. Ooh, there's one that's 9 minutes. So this gets you through the mole. This gets you through bonding, dot structures, molecular shape, resonance, and that should cover all of it. So that's the material you need to learn in order to get through the rest of the material. Let's go back. And I think about the only thing that remains here once you've done this is to get ready for that quiz. So let's take a look at a few of the topics here. Don't forget that if you click here, you can listen to me go over the whole thing, which is kind of what I'm doing right now. So what would those terms, the mole and stoichiometry, mean to you? Well, for the mole, I'd say it's just a number. And for stoichiometry, I'd say that means literally stoichion, meaning element, and metron, meaning measuring. So this would be just a large collection, right? Not a dozen, not a ream, but 6 times 10 to the 23rd worth. And stoichiometry, element measuring, mostly conversions from grams to moles to molecules, that sort of thing. Molar mass of aluminum chloride, I'd use the periodic table to find the average atomic mass of each element, and I'd see that aluminum checks in, I think it's at about 27, each chlorine checks in about 35.5, and there's 3 of them, and I'd total it up. What's the percent composition of ammonia? Well, I'd recognize that nitrogen is 14 grams per mole, each hydrogen is 1. So if you had 17 grams, you'd have a mole of nitrogen. And in terms of its percent composition, well, 14 out of every 17 grams came from nitrogen. That would check in at about 82%. And only 3/17 of it by mass is hydrogen. That would be the other 18% or so. And continuing on like that till you've gone through each of these. And here's the answers to each one. So you can use these like flashcards, learn each one. Once you've gotten through the last one, you are ready to take the quiz. And it's a timed quiz. Good luck on that. I think that's the last slide. Okay, let's go back. I hope that helped you all. I hope that you can get through this. Let's go over timing before we call it. We're now already to Tuesday, so I would recommend take just a little more time if you need to watch the videos and do the lessons that are in Blackboard, being selective, only doing what you need. Tomorrow, well, I understand that there's the holiday going on, so take any of this with a grain of salt. But around the following day, if you were done with the lessons, that would be great. If you started the labs, that would be even better. If you're really pressed for time, try starting the labs even tonight to see if you can get through them. And after that, it's only you just complete the assignment, take the quiz after you do the review, and if you did all that, you'd be a day ahead of the game with nothing to do on Sunday. So choose your own timing. Good luck, everybody, and email me if you have any questions. I'll be around all week, so if you get stuck on things, don't be afraid to reach out. Okay, everybody, have a wonderful holiday.